In my projects, I widely use Full AI, which provides various cloud-based models. One of the models is Full AI Demucs. It's deep extractor for music sources. Where you upload an audio track and get separated stems. So when you click more, you can select a model, and the default one is HTDMAX 6S. So actually, the full AI Demucs model is cloud-hosted version of the Facebook Research Meta Demucs repository. So HTDMux is first version of hybrid transformer Demucs. Trained on MuseDB plus 800 songs is default model. HTDMux 6S is 6 sources version of HTDMux with piano and guitar being added as sources. So I I built a small Python application that can run locally and generate stems. I ran the model on CPU because it's relatively lightweight, but I also tested it on XPU since my notebook supports it. The results were about 3 times faster on XPU, so a 4-minute track takes around 45 seconds to generate stems, while on CPU it takes roughly 3 times longer. However, I will run it on CPU as the difference is not critical for my use case. The setup.bat script sets up virtual environment, installs all required dependencies from requirements.txt, and prefetches the Demucs model weights. So the model weights are stored in the default cache directory at C users HP cache in my case, and specifically within the torch folder. I will remove the folder and rerun the script bat script. So during execution, the script will skip reinstalling dependencies as they are already present and proceed to prefetch the Demucs weights. You can see it's downloading from the API publicsfiles.com, the th file. So th file here is almost always a PyTorch checkpoint. It's the trained weight and sometimes extra metadata saved to disk. So we will run the application to generate the separated stems and then move on to debugging. The application runs locally on localhost using Gradio. I'm uploading an audio track created with my Suno Web Studio. Let's listen to it first before proceeding.
Yeah, greetings in the name of the Most High. A través del valle, hallamos la luz, levántate. Sunrise in the morning, I see the shadows start to run. Another day of living beneath the golden island sun. The concrete is burning, but my spirit is feeling cool. I'm walking with the wisdom, I'm nobody's plaything or fool. Siembro la semilla en un suelo seco y cruel. Veo niños jugando said, for the soul that wants to be free, I'm washing off the dust, of 1,000 weary. Caigo de rodillas,
I fall to my knees.
para ser más feliz. No quiero el poder, ni tampoco una corona. Levanto mi was closed and the gates were locked tight. Pero hallamos las llaves en el ritmo del barrio. Gloria, rompe las cadenas. We walk in the road, carrying the hope of the elders. Building the home, es la brújula al amanecer.
But love is the compass sat down.
The journey, la misericordia.
So I'm clicking the separate button. This is running on the CPU and it takes 3 times longer than on my XP. Now I have 6 separated stems. Let's test them. It's drums. Sure. Um, vocals.
Yeah, greetings in the name of the Most High. A través del valle, I have another day of living beneath the golden island sun. Siembro la semilla en un suelo seco y cruel. Veo niños jugando bajo el cielo de clavel. No quieren home, being the spiritual shelters. Intentan dividirnos, perdernos en el ayer. Pero el amor es la brújula para hacer más una corona. Levanto mi espíritu. The gates were locked tight. Gloria, rompe las cadenas. We walk.
System separation application is a small Gradio web application that uploads a mix and runs Demucs in PyTorch so you can split it into separate stems and play them in the browser. Gradio is a Python library for turning a model or script into a small web UI without writing HTML or separate frontend. You describe inputs, text, images, audio, files, sliders, etc., and output, wire them to Python function, and Gradio serves a page where people can try the model in the browser. The setup.bat calls load pipeline, so Demucs downloads and caches the model weights the first time instead of waiting until you click the separate button in the application. Let's debug the application. When the user clicks the separate button, Gradio runs on separate with the current upload as an audio. If the file was provided, it first calls load pipeline. So Demucs separator is created. In Demucs high-level API, separator is the object that owns the loaded model and knows how to run separation on a file. So now the audio part is passed in the separate audio function. So separate audio. So this separate audio file method in debug separator, it reads your input file and runs the model and returns two things in tuple. So the separation started. So the separated is the part we care about. It's a mapping, usually stem name, tensor, for example, drums, bass, vocals, each with separated, each with the separated audio for that stem. So the separated is the dictionary. Each key is a stem name, like drums, vocals, and each value is that stem's waveform data. A tensor Demucs can write out. This underscore is Python convention for, like, I'm ignoring this. So the first return value is something the API also gives back, often the original mixed tensor. Our application doesn't need it for saving steps. So the loop works the dictionary for each stem and source. And Demucs API save audio write source to that path as wave using the separator's sample rate, and as float equals true, so the file is written from floating point samples. So this return result gives back a dictionary mapping, stem name, and the path to each wave file, which app py uses to feed the audio layers. The separated stems are written as wave files under the output. Each run its own subfolder whose name includes data and timestamp, so every separation run keeps its files in separate folder. So this stem updates from paths turns the paths dictionary from separate audio like the stem name file path into tuple of Gradio updates for the 6 stem audio component.